Alright, in this worksheet, we're going to start talking about probability. This corresponds to the book chapter 3, section 3.1. The concept of probability is used to bridge the gap between population and a sample. So we have our sample here, we have our population here, because when a sample is selected from a population, not everyone from population is selected. Only portion of it is selected. So it's like who's going to be selected and who's not going to be selected. It's kind of left to chance when you pick a random sample. So by studying the properties of probability, we can better understand the property of a sample. Okay, let's look at the first one. The probability experiment is a procedure whose outcome depends on chance, as we mentioned before. So basically selecting a sample is a probability experiment, because who's selected or is not selected is left to chance. For example, rolling a 6-sided die, looking at the result. So I don't know if you guys have played a dice game. That's not a good dice. So if I were to draw it, it's basically a cube, has number 1 through 6 on it, and you roll it and whatever number shows up on the top will be the result. So we don't know it's going to be 1, it's going to be 2, it's going to be 3 or 6. It's kind of left to the chance. An event is an outcome of experiment. So for example, getting 6 on your die, 1, 2, 3, 4, 5, 6, that can happen, right? Or getting an even number, it could be 2, 4, 6. They're just example of events. Simple event, on the other hand, is event that cannot be broken down into smaller events. For example, getting 6 is a simple event, but getting even is not a simple event, because even has 2, 4, and 6, right? So even number can broken down into either getting 2 or getting 4 or getting a 6. So there are 3 different events that makes up an even event. Whereas getting 6 is just 6, that's it, right? So that's the difference between simple event and just event. A sample space is a collection of all simple events. For example, the sample space of the experiment from number 1, which is rolling a die, is set 1, 2, 3 all the way to 6, right? I can also think of sample event as all possible outcomes, right? So this one means write down all possible outcomes. Maybe one more example. Let's say I have a student, 5 students. I have 3 red student number 1, student number 2, student number 3, and then I have 2 blue student, right? So if I pick a student at random, right, I could pick a blue student, I can pick a red student. So a possible event could be picking a blue student. Possible event could be picking a red student. That includes 1, 2, or 3. Or possible event could be just picking one student in particular at random, right? So it's kind of like a sampling. This could be my population, and I'm going to sample, and it could be, my sample could be containing red students, it could be blue students, or particularly the student number 1. So these are just different type of events. My sample space will be all possible outcomes. So it'll be 1, 2, 3, 4, 5, right? And in a bit, we'll talk about what's the probability or likelihood that I'm going to pick somebody who's blue, or somebody who's red, or this particular person. Okay, and I'm going to have you pause and look at work on number 6. All right, now look at number 7. So basically, how do we actually calculate the probability? There are 2 approaches we can take. If you look at number 8, it's the relative frequency, which we talked about already before, so that's something kind of old. But classical approach, which we're going to use more in this class, is that we calculate the probability of event A by counting simple events. So probability of A is equal to the number of simple events in A and then total number of simple events. Basically, I can interpret this as how many are in A on top, and the bottom, how many are in the sample space. How many are in the sample space S. So if I were to kind of go back here with my red student and the blue student example, if the question is, what's the probability I'm going to pick a blue student? Basically, I'm looking at the event, blue student event, they have number 4 and 5 student in it, so there are 2 students, so it'd be 2. And on the bottom, it'd be my sample space, which has 1, 2, 3, 4, 5 things in it, so 5. So this is how we'll be calculating this probability. So that's what the classical approach or theoretical probability is telling you to do. Relative frequency approach. Relative frequency, we talked about it when we were creating frequency table. So basically the same concept, that I can just interpret that as a probability. So probability is A by repeating experiment many times and counting the number of times A has occurred. So A has occurred, number of times the experiment was performed. All right, let's look at a few questions here. Let's do it together. It says, identify if it's theoretical or experimental. It's not that important concept that they're different, but just kind of look at it. Probability of getting, let's look at the first one. Probability of getting a 6 when rolling a die is 1/6. That's the theoretical, because there's 6 possible outcomes, and getting 6 is only one outcome out of those 6. Number 2, rolling a die 5,000 times and dividing the number of times you get 6. So here it feels like they're repeating experiment bunch of times, and they're trying to count how many times you get 6. So that looks like experimental. Probability of passing step 50 is half because you either pass or fail. That's incorrect, right? Here I have to look at how many people are taking stat, and I have to count the number of people who are passing the class to calculate the probability of somebody passing the class. The last one, randomly selecting 304 most 50 students. Yeah, this is what I was kind of talking about, so that would be experimental. Okay, some properties of probability here, kind of important. So your probability is going to be between 0 and 1. So 0 is 0%. 1 is 100%. Again, how do you convert decimal to percent? You basically multiply 100, or you move your decimal 2 to the right? Move decimal point 2 to the right. So 1 is the same as 1.00. So like 1.00, move your decimal 2 to the right. So it'll be 100, which is 100%. So these are two good markers. You know that 0 is 0%, that's easy. But I want you to kind of remember 1 is equivalent to 100%. These are two extreme probabilities. So when probability equals 0 means A is impossible. When you have 0 probability, that means it's not going to happen. When you have probability 1, which is 100%, if something is 100% probability, that means it's a certain event. That means it's for sure going to happen. Notice that there's no such thing as 120% probability, even though like in real life maybe we use that, but in probability, like mathematically 120% probability doesn't make exist. Same as like negative 5% probability doesn't exist. So probability has to be between 0% and 100%. Now I'm going to look at some more interesting events and looking at the probability of interesting events. So first you see it says A or B. So imagine so for example, to satisfy your math requirement, you have to take either step 50 or math 15. For some schools, you can either take step 50 or math 15. Some schools, they want you to take step 50 specifically. But a lot of schools, they'll say step 50 or math 15. So if I want to look at people who satisfy those conditions, either there are going to be a lot of people who took step 50, that's fine. People who took math 15, that's fine. It's going to be a bigger group. So it's called A or B, step 50 or math 15. It's a collection of elements. We include elements if it is in A or in B or both, right? So if you took step 50, you're good. If you took math 15, you're good. So for example, the first group has 1, 2, 3 in it, and the second group has 2, 4, 6 in it. Then A or B, here, they're using this symbol. We're not going to use it. We'll just call it A or B. That symbol will contain person number 1, person number 2, person number 3, 4, 6. There are just a lot of people, because they either took class A or class B, right? Whereas when it says A and B, that means you have to take both classes. So in that example, it's like 1, 2, 3, 2, 4, 6. 2 is the only person who took both classes. So for example, like English 1A, to satisfy some conditions, you have to take English 1A and English 1B. If they say 1A and 1B, that means you have to take both classes, right? So in order to be in the set A and B, you have to be in a set A and also in B too. So for example, this example, one person took 1A but not 1B, so this person is not qualified, or this person doesn't satisfy this condition. Complement just means whatever is not in the set. You see A with a little dash or A with a little bar. So complement is whatever is not in the set. So A is 1, 2, 3. So A complement is whatever is not in A. So who's not in A? 4, 5, and 6. So I can think of complement as the opposite set, right? Did is the opposite of A. Sometimes you see it as A with the bar. Sometimes you see A with the little dash. The next one is conditional probability of A given B. I'm going to just highlight the given B part, which is written as A and then bar B. This means you're going to calculate the probability of A with the assumption that B has already happened. Another way to interpret this is A out of B. For example, in a class of 100 students, there are 60 freshmen. Out of those 60 freshmen, 30 are in pathways. So it says probability of pathway given that somebody is freshman. Basically what happens is our number on the bottom denominator is not going to be 100 out of 100 people, but it says given freshmen, so I'll look at only freshmen. So it'll be 60 on the bottom. See, out of this is B part. And then there were 30 pathway students. So the probability of pathway given the freshman is 30 over 60, not 30 over 100. So that means B becomes our new sample space. That's why I put the 60 on the bottom. Okay, I'm going to get you started on the next question. We'll do few questions together, and then I'll have you finish the rest of it. So sample space is whole number starting 1 and less than 20. Okay, fine. So 1, 2, 3, 4, da 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 da. It says less than 20, so I'll stop at 19. Let A be even number, B is greater than 13, so even number is 2, 4, 6, 8, 10, 12, that's a lot, 16, 18. And B says number greater than 13. So greater than 13 is not 13, but it starts at 14. It's bigger than 13, so it'll start at 14, 15, 16, 17, 18, and 19. So these are my two sets. So when they ask probability of A, I'm thinking there are 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 numbers in it. So it must be 9 over 19. So why is it 9 over 19? Because S says there are 19 numbers in it. There are 19 numbers in it. That's why it's 9 over 19. And look at part D, A and B. Again, it says A and B. That means you have to be in both A and B as well. So let's say I'm scanning through these numbers. What numbers are in A and also B? B's are the big numbers. A's are even numbers. So if I'm looking at, it starts from 14. So there's my 14. There's my 16. There's my 18. So there are 3 numbers they have in common. So here I'm going to say A and B has 14, 16, and 18, like this. Okay, I'm going to pause now, and then I'll have you finish the rest of number 15. And also have you work on number 16. Somehow it got printed kind of weird, so this part doesn't exist here. That one was for the next question, number 17. There's left-handed and right-handed. So left-handed here, and the right-handed. Sorry about that. Okay. And this will conclude this worksheet.